Hi, this is Ms. Claywell. This is a video on 4.2, perfect squares and perfect cubes. The very beginning of your note should be crossed out, so we're going to jump down to this part where it is talking about how to factor difference of squares. So we're going to talk about how to factor difference of squares. First, we want to make sure we have a binomial, which means two terms, so like something plus or minus something, so just two terms. Then we want to factor out the greatest common factor. If both terms are perfect squares and have a negative sign, we can use something called difference of squares. So if I have something squared minus something squared, this becomes a plus b, a minus b. So we find the square root which means basically just find a and b. Make sure one has a minus sign and one has a plus sign. So the formula that we're going to keep coming back to for this first page is a squared minus b squared is a plus b times a minus b. Okay, so with this a plus b, a minus b in mind, I'm going to look at these three examples and see. Step one, do I have two terms? Yes. Step two, pull out a GCF. I see a 2x in common. So that becomes an x squared minus 16. Look above. If I have subtraction in between, and both these are perfect squares, I can identify what my a and b are. What times what is 16? That's a 4. What times what is x squared? That's an x. So I'm going to do a minus b, a plus b. But instead of a plus b, I'm going to write my x plus 4. And I keep my greatest common factor on the outside. So look at example 2. I pull out my GCF. I'm going to pull out a 2. They don't have an x in common, so I can just pull out a negative 2. I'm thinking, if I can write this as something squared minus something squared? That's a 3 and a 5x. So my a is a 5x, and my b is a 3. And then I'm going to use this equation that my a plus b, a minus b, and I need to write my GCF that I had on the outside. Last one, GCF here is 25, or 4, sorry. Let me see if I can write this as something squared minus something squared. 4 times 4 is 16. 5 times 5 is 25. 5x and y. So here's my a, and here's my b. So I do a plus b, a minus b. If I did those in a different order, that's okay. If I did this shouldn't be b, my b is 4. If I did, it doesn't matter if you do the a plus b first or the a minus b first, as long as you have both of those factors there. Okay, looking at the next part of this, I'm still going off the same idea. Okay, I'm going to plot a GCF, step 1. Okay, I can write this as something squared, but I don't have subtraction in the middle. So even though I can identify an a and b, I don't have subtraction. So since I have addition, this is not difference of squares. So since I have something positive, it can't be difference of squares. If I pull out this one, these would have a 2 and a 4 and an x. So I can pull out a 4x. These are not perfect squares. So I can't continue. Same with example 4, it's not difference of squares, so I can't continue. Last one, I can pull out a 4. Five and 6 are not perfect squares. So I can't continue. So I would just factor what I can. Okay, once you're done with this, flip to the back page. We're going to talk about the next way to think about this. So if you were to take the time to box this, have an A and a B, sorry, I'm going to write that a little neater. Okay, so I boxed both of these. I want you guys to fill in the boxes. And if I were to write out the only thing I'd have left is a to the third plus b to the third. If I did the same thing over here, and I try to see what this becomes, I see two patterns that what the answers I get are binomials, meaning there's two terms, and then I have perfect cubes. So basically I have something cubed plus or minus something cubed. And this is what we have with difference of or sums of cubes. So I'm going to take a second and list all your perfect squares. You can use a calculator if you need to. And we're going to keep those in mind as we work through this. So I'm going to look for a GCF. For this one, step 1, I see a 2. I'm going to write as something cubed minus something cubed. If I look above, what times what becomes 8. That's a 2. So this is my A, this is my B. Then I'm going to use one of these two formulas. So because I have subtraction, I'm going to use the 8 something to the third minus something to the third. Everywhere I see an A, I'm going to put a W. Everywhere I see a B, I'm going to put a 2. And I want to keep this 2 with me. I can't factor this any further. Okay, something that's helpful to remembering the signs, we use the saying SOAP, which means the same, O, which means opposite, and the last sign is always positive. So SOAP is a way to remember what the signs are. Okay, let's start these examples. I'm going to see if I see a GCF. I see a 2 and an X. Something of this is something cubed plus something cubed. Look at the very top of this page where you broke things down. This means that my B is 4. I know I'm going to have an X here and a 5. So I'm going to use my A plus B A squared. Here, I'll write out the. So here's my A times B plus my B squared. Oops, I should have written my B here was 4. So I saw that this was sums of cubes, so I used the sums of cubes formula. Go ahead and look at example 3 on the next page, and then I'll start a new video. So look at example 27. Is my greatest common factor? I can think of this as something cubed minus something cubed, u and 2. So I use a minus b, a squared minus, or a squared plus a times b plus b squared. If you don't need to write it, rewrite it, that's fine. But I have my 27 in my front. Here's my a, and here's my b. So 2 minus u, 2 squared plus 2 times u plus u squared. So if you want to rewrite that, that's what this would become. Okay, I'm going to post a second video with the rest of this page. So make sure you watch that.